If we are trying to solve a system using substitution, we need to have one variable completely by itself on one side of the equation. And I want you to do the least amount of work possible. I like to call this being strategically lazy. So in this top equation, could we get this y by itself fairly easily? All we would have to do is subtract x on both sides. So let's do that. Y equals negative x plus 4. I'm also going to put that in parentheses just to remind myself that when I stick this into the other equation, parentheses around it are going to be very important. All right, this is going to go in place of this y. So we're going to take this y out and put negative x plus 4 in its place. It's kind of like this second y is the quarterback and he falls and breaks his leg. So the backup quarterback, negative x plus 4, is going to go in his place. Now that's not going to happen this weekend, right? No, yes. Everybody knock on wood. Mahomes is not going to get hurt this weekend. If you're watching this video a year from now or 2 years from now, this is the year we went to the Super Bowl, by the way. Just to clarify that in the video. Okay. And the Super Bowl is like in 2 days. Okay, so x minus, and instead of that y, we are going to put the parentheses negative x plus 4 in its place, and then continue with the equals 2. Our goal here is to get all of the same letter in this equation because then we can actually solve it. Now, the thing about a minus and then the parentheses, we have to distribute that negative. So this is actually x plus x minus 4 equals 2. Now we need to finish solving. X plus x is 2x. We have 2x minus 4 equals 2. Is that an equation that we can fairly easily solve? Add 4 to both sides. 2x equals 6, which means x equals 3. Your answer for this is going to be an ordered pair. The x comes first and then the y. So now we have to go back and figure out what y is. But the easy thing is we're going to use this equation that says y equals. So if we plug in 3, y equals the negative sign, then plug in the 3 plus 4. Negative 3 plus 4 is 1. So our final answer is the ordered pair 3, 1. This means if you use 3 in place of the x's and 1 in place of the y's, the top equation will equal 4. The bottom equation will equal 2. If you were to put both of these equations on a graph, the two lines would cross at the point 3, 1. Okay, I do really, really love substitution when our system is set up the way that this next one is. This next one says that y equals this stuff. And the second equation says that y also equals this other stuff. So do you remember something from geometry called the transitive property? If A equals B and B equals C, then A must equal C. Well, y equals stuff. That stuff also equals y. Y equals y. So what do you know about the two green things? They have to equal each other. So 5x plus 12 has to equal negative x plus 6. That plus looks weird. Add x to both sides. Subtract 12. So x equals negative 1. When we go to plug that negative 1 in, you can choose either equation. I'm going to choose the top equation because the top equation doesn't have any negative signs in it. So y equals 5 times -1 plus 12. -5 plus 12 is 7. But you could also plug it into this bottom one. -1, so that'd be +1 plus 6 is 7. It doesn't matter which equation you choose. Use the one that you feel looks the easiest so that you will make the fewest mistakes and get the answer -1, 7. On these two examples, they are not set up nicely for substitution, but again, I want you to do the least amount of work possible. So when I look at this example 3, I see that the first x doesn't have a coefficient. There's no number in front. So I could pretty easily add 3y to both sides to get x equals 3y plus 2. I want you to look for the equation where you could get that letter by itself using only one step. And again, I'm going to put parentheses around the 3y plus 2. This time x equals, so we're going to be taking the x in the other equation out and putting 3y plus 2 in its place. So we've got -2. Instead of that x, we have 3y plus 2 plus 6y equals 2. Take a moment on your own, distribute, combine like terms, start solving, and see what happens. Once you distribute, you see that you have -6y and +6y. Those are going to cancel each other out. That would be 0. And we're left with -4 equals 2. Does -4 equal 2? No. No, this is a false statement, which means there are no solutions. If your variables eliminate and you're left with something that is not true, that means it's not possible. If you graph these two, they would be two lines that are parallel, that never ever cross, never meet. They never share a point. There's no point that they have in common. The next one, which letter looks the easiest to get by itself in one step?
Y.
The y. So we subtract, we get y equals -3x plus 5. And I always try to put parentheses around that. So the y in the other equation is where we're going to stick that -3x plus 5. So 9x plus 3, instead of the y, we put in -3x plus 5, and then continue with equals 15. Take a moment, distribute, combine like terms, see what happens. 9x minus 9x, those cancel out, and we're left with 15 equals 15. Does 15 actually equal 15? This means that there are infinitely many solutions. Or if you just want to write many solutions, that's fine. Basically, this is a line. So the first equation would give you a line that looks something like this. The other equation would give you the exact same line. So every single point on one line is shared by every single point on the other line. There's tons and tons of solutions. Okay, next is the word problem. Here's my guess. Most of you feel pretty good about solving systems of equations until we get to the word problem, then you're like, all right, I'm out. Word problems are not that bad. We just have to figure out which type of word problem this is and what pattern it follows. There's a couple different types of word problems, different patterns that we'll see. This one's about a farmer, so because apparently we're in Cowtown, so we talk about farmers, even though we're a metropolitan area, whatever. A farmer wants to mix two types of hay. The first type sells for $125 per ton. The second type sells for $75 per ton. The farmer wants a total of 100 tons of hay at a cost of $90 per ton. Okay, there's a couple different pieces of information that I see here. One of them is there's definitely information about the cost of things. There's also information about the amount of hay. We're going to call this first type type A and the second type type B. So I'm going to kind of make like a little table here. We're going to have information about type A, information about type B, and then I also see information about total. There's total cost and there's total amount of hay. This word right here is a very powerful word. Anytime you see the word per after something like price, that means multiply. $125 per ton. So 1 ton is $125. 2 tons is 2 times $125. 3 tons is 3 times 125. So this cost for type A is 125 times the number of tons of that type of hay that we buy. What should I put underneath B? 75. And we'll use the other letter, Y. We're going to add those up, and it's going to equal the total cost. But I'm going to have you pause on the total cost. We'll come back to it. Now the amount. If X is the number of tons of type A, we're going to have X plus Y, the number of tons of type B. How many tons total does the farmer want to have? 100. So these things come from where I highlighted blue. This is the stuff that I highlighted green. This is the stuff that I highlighted yellow. All right, now let's talk for a minute about this total, because it's not 90. He says $90 per ton. He buys 100 tons. So what's that going to be a total of? How much money? 9,000. 90 times 100. So they don't actually give you all the information exactly how you need to use it, because they're saying that this total needs to cost $90 per ton, and we're buying 100 tons of it. That means we're going to spend $9,000 on this hay. So that's where that number comes from. Now, do you feel like once you get the equations set up, do you feel like you could solve this if you needed to? You'd probably get y by itself in the second equation, stick that in place in the other one, and you'd figure out how many tons of type A and how many tons of type B. I feel like on word problems, getting the equation is the hard part. After that, the rest of it's just easy. So on your assignment, I have actually already changed the assignment. It starts on page 381. I've reduced the number of problems and changed it a little bit. I want you to do numbers 15 through 17, 26, 28, 45 and 46 are the word problems. You don't need to solve those. I just want you to try to write the system of equations. And be brave. Try writing them. If you get them wrong, that's okay. Tomorrow we can look at how you wrote them wrong, what you need to do instead, and that will be an opportunity for you to learn, because mistakes actually help you to learn and improve. So be brave. Don't give up on the word problems. Just try to write the equations. We'll look at them tomorrow and adjust them if necessary.